Hey, are you here to do logic? Because that's what I'm here to do. These are logic videos. I'm Scott Aiken. You're you. We are going to be talking about inclusive and exclusive disjunction, how to represent them with the tools we've got in this formal logic. Then we're going to be talking about some neither nors. So let's start with a kind of a familiar inclusive disjunction. Anyone who's known ambitious and intelligent college students have known that, for example, Andre, our friend Andre here, he could be a chemistry or a philosophy major. Notice, by the way, so we'll have, that's a complex predicate, chemistry or philosophy major, C, vel, P. And one of the important things is that that's an inclusive disjunction. Andre could do both. He could be a double major. So he could be, there's Andre being a chemistry major, that makes it true. Andre being a philosophy major, that makes it true. Andre being a double major in the both of them, that makes it true. So, crucial thing, sometimes in natural language and sometimes in English, or is inclusive. We've got a case of that there. Now, we've got other cases where the ors are definitely exclusive. And we want to be able to represent that because that's part of the information that's going to be relevant to our being able to make inferences. So, let's take a look at this one. Shatima, she's 10 or 11 years old. So let's represent that first with just as a regular old disjunction as an inclusive one. There's our complex predicate. We'll use T for 10 is 10 years old, or E for 11. Okay, so let's think for a second. Shatima is 10. That gets captured by that T. Shatima is 11. That gets captured by the E. Either or, that's fine. So if she's 10, comes out as true. If she's 11, comes out as true. The problem is that we also need to be able to represent the fact that she can't be both 10 and 11. Can't be both. Now, here's the crucial thing. But not both. She's 10 or 11, but not both 10 and 11 can be represented. How? Well, it turns out that we just said the words, but not both. Those are all truth functional connective functions. Let's show them. But not both. So there's 10, 11, but not both. 10 or 11 inclusive, but not both 10 and 11. That eliminates the top line of your truth table. Nevertheless, is perfectly consistent with a case where there are going to be instances where one or the other. So we have a case where we can represent exclusive disjunction by making explicit disjunction, but not both. Okay. Good enough. Well, what about neither nor? Well, so let's think about what neither is. What are we saying whenever we say neither? We're saying not either. Either. Not either. It's a little compression of those two, or an elision. So what we're going to do is we're going to say, if that's not either, let's at least represent the either. Either Young or Gabriel had dessert. So there's Young, or there's Gabriel having dessert. And we are saying not either. Neither nor. Okay, so far we've been able to represent some inclusive disjunctions, some exclusive disjunction, and be able to say but not both. And we've also been able to represent neither nors. Now that we've got this in place, we've been able to represent some natural language coming in. We'll have some more complicated stuff that we'll talk about in class with being able to represent non-truth functional propositions, both as components and also larger truth functional stuff as components of non-truth functional propositions. That's a little bit more complicated, takes a little bit more time, so that'll be something that we do in class. But on the other side of this, in the next couple videos, we're going to be talking about how to compute the truth functions once they're in, and how to start testing for validity in these logics. That's next. See you next time.